So during this video what we're going to be doing is going through our second task in relation to PN4036 week 10's lab. So if you look here, first of all, what we're given is basically the shell of a hyperbolic paraboloid. Now what you're looking at here is, I suppose, it's very important to have a better understanding of what a hyperbolic paraboloid actually is and what it's made up of, and what key terms are used when talking about this particular topic. So what I would suggest again is that you would go off, get your Anderson's book, have a look through that chapter, read through it, get a bit of an understanding for it. As well as that, we have added, I suppose, a model, a SOLIDWORKS model in relation to this question, and another question that will be in the additional question section on SOLIS. That will help you, I suppose, better understand what you're looking at here. So if we first, I suppose, read the question up the top left. So given two skewed lines, directrix AB and DC. So as you can see here, it's AB in elevation and CD in elevation, and then below here in plan you have A to B and then C to D. Now what gets confusing here, I suppose, is the placement of the points when they're on the XY line. It's sharing points, so for instance here B and D are on top of each other. But then when you look in elevation you can see that B is actually above it and D is below it. It's just, I suppose, being put in a certain way that it's tough to visualize. The first part of the question is find and identify the edge view of any plane director. Okay, so this is actually a lot easier in this particular drawing due to the way that it's resting on the XY line as well as pushed up against it both in elevation and in plan. So for this, all we have to do is look at a line that's resting in plan on the ground, which is our AD line. What we can do is extend that. So when we extend that and give ourselves a perpendicular line to creating an auxiliary view, what we're doing here is basically looking at AD as a point view. So what we're seeing then basically is that A and D will share a point above here. So I'll just call this A/D. And then we can just take up our other points. Now we also know that C is going to be resting on the X1, Y1 line. So we know C is going to be resting here. Now we just have to get our height for our B. Get that distance. Mark it off. And also label that as B. Now I'm just going to brighten this up with a small bit of colour so it's a bit clearer. It's going to be our B. Okay, so now what I'm going to do is join up my lines so I know AB is connected. DC and B back to C. So what I can do here now is I can start to develop, I suppose, my plane director. So now I could have multiple planes that are going to be cutting through this particular hyperbolic paraboloid, which will then, I suppose, produce lines on the surface which will act as generators, or they're also known as directrix. So if we look here, I can start putting lines parallel to this line here, and what I'm going to do is I'm going to BC, I'm going to do 4 of them evenly spaced. So if I just divide up my line, four. Like so. 4 parallel lines. To basically get 4 lines on the surface of my hyperbolic paraboloid, like so. Now I'm going to also extend the line out here just to show that this is my plane director. Now what I can do is carry each of these lines back and basically show them in my plan and in elevation. Now what I'm going to do first of all is I'm going to label them. I'm just going to use 2 different colours to label them, and I'm going to call this one 1 in orange, 2 in orange, 3 in orange. Do the same below here, 1 in blue, 2 in blue, and 3 in blue. Now, just make this clear, they're in relation to these points above here. I'm going to carry them back. So I'm carrying back to the AB line first. Then I'm going to carry this back to the CD line. So if I carry these back, now what I can do is join them. Now I can also carry these up into my elevation. So if this is on the AB line, carry them up to AB. Carry these up to the DC line. And join them up again. Like so. Now, once you have that completed, you've completed, I suppose, the first section where you're identifying the edge view of the plane director, which you can see here. Also, you have taken down your elements below here and just displayed them so everyone can see as, I suppose, the different planes are cutting through the surface of the hyperbolic paraboloid, I suppose, developing these lines which are known as genetrics, which are then carried down through and shown both in plan and in elevation. Now after that, the second part of the question is find and identify the trace, which is the VTH for the plane director. So what you can do here is you can just carry back where your plane director is hitting, I suppose, the XY line, which is this point here, travels back. Also, then you need to identify where it is above here in plan. So you can imagine that because it's travelling back here, this is already RT, we know it's this point, and this is an RH in our horizontal plane. Now we need to find the point on our vertical plane, so what we can do is pick any point along here. I'm just going to say this point here. Carry that back till it hits the XY. Bring that directly up. Get the distance that I took from here. Mark that off. And then travel a line from the T here, which is also A, through that point. And now this is your VTH. Now I know that can be a small bit confusing seeing how this auxiliary view is being cut by your VTH. If I was doing this again, what I do is move my X1, Y1 line further up just to keep it out of the way of the VTH, that they don't be overlapping. But once you have that completed, you have the question done.